Trig Quiz 2. Here we go. Oh, and I think I am in, yeah, I just taught Math 12. I'm in radians. I need to be in degrees. Solve the following. Give your answers to one decimal place. You must show at least one line of work for each question. Basically, I'm going to give you 1 mark for the correct trig function, 1 mark for the correct answer. All right? 2 marks each. Number 1, I think your equation ends up being x squared plus 8 squared equals 10 squared. That'll get you 1 mark. Then I think it's going to be x squared equals 36. If I do the math right, is x equal to 6? Hey, I did that one in my head. Yes, it can be done. Well, as long as they work out evenly and you know your squareds. 1 mark, 1 mark. So give yourself a score out of 2. Number 2. I think you're going to get, running out of room here, how about 10 squared plus 24 squared equals y squared? You get 26. I'm going from memory here. Okay, I won't be fussy except on a test or a quiz. I would. The only issue is if you got 0, if you got this wrong, I have to give you 0. Where if you had this and then did something dumb on your calculator, I can still give you 1. So if you got the right answer, 2 out of 2. Okay, but the risk you're taking is if you make a dumb calculator mistake, I can't give you part marks. Specifically, when we get, oh, one more Pythagoras here. This one won't work out evenly, I don't think. You get m squared plus 19 squared equals 24 squared. 24 squared plus, Mr. Dueck, minus 19 squared. Come on, calculator. 19 squared. So you get m squared equals 215. And then how do I get rid of the squared? Square root. Alyssa, I guess the short answer I have is I kind of like it when you don't show work in your homework because that tells me you're confident and doing well. As long as you're checking your answer and making sure you get it right. Right? Okay. So 14.66, 14.7. Now we're getting into the trig. Opposite, hypotenuse, sine of 45 equals 16 over x. Have you spotted the shortcut yet, Joel? If the x is on the bottom, it's going to be 16 divided by the trig function. If the x is on the top, it's going to be times. It's going to be 16. It's going to be 16 divided by sine of 45. You get 22.6. So if you got 22.6, Alyssa, 2 marks. If you got this wrong, but you use sine, you get at least 1 out of 2. That's how I'll mark these on a test. That's the risk with not showing any work, is if you get it wrong, okay, can't give you part marks. Opposite, adjacent. Hey, that's a tan. 62 equals 19 over y. 19 divided by tan 62. You get 10.10? 10.1? Opposite, hypotenuse. That's a sine. 34 equals 8 over x. It's going to be 8 divided by, what was the angle? Sine of 34. You get 14.3? Should. Opposite. Pardon me? Everything's 2 marks. 1 mark for the trig function, 1 mark for the answer. If you got the right answer, 2 out of 2. If you got the wrong answer, but you did use sine, and you did something wonky on your calculator, you get 1 out of 2 at least. Is that okay? Tan 22 equals, it's not tan, Mr. Dueck. Good gosh, it's not adjacent, Mr. Dueck. Good gosh. Is that why you asked? Because I made a mistake. How about let's call that hypotenuse, Mr. Dueck. Good gosh. Sine 22 equals j over 12.3. It's It's going to be 12.3 times the sine of 22. 4.6. If I'm wrong, by the way, give me a holler. I'm just doing these really fast. Adjacent, apparently too fast. Cosine 36 equals x over 19. It's going to be 19 cos 36. 15.4. How many of you perfect on the first 8 questions? Lottie, good. Number 9. Okay, now we're finding angles. I still start out by labeling opposite, hypotenuse, sine. What always goes next to the trig function? The angle. 4.6 over 10. How do I find an angle? Darn right. Steph, the back room is open now. If you want to write back there, you can. Okay. Second function of 4 point, come on, 4, there we go, 0.6 over 10. You get 27.4 degrees? Yeah. Hypotenuse adjacent cosine of theta equals 9.1 over 14. Once again, Tanner, you're right. It's going to be second function. How about typing it in? Come on. You get 49.4? 49.5, I guess. A few more angles here, Mr. Dueck. Adjacent hypotenuse. Oh, this isn't an angle. This is finding a side again, Mr. Dueck. It's cosine of 71 equals 9.1 over x. It's going to end up being 9, come here, 0.1 divided by cos of 71. 27.9, I guess 28.0 if I go to 1 decimal place. I'll think bad thoughts about you and I'll say, oh, round off properly for Pete's sakes. I'll take the marks, but, you know, let's round off properly. Adjacent hypotenuse cos of 68 equals adjacent over hypotenuse. Yo. Yeah, apparently it is, Mr. Dueck. That's what I meant. Yeah. Whoops. So you're saying it's sine, I hope. Sheesh. That's good, because I was going, why did I do so many cos questions in a row? That's a dumb quiz. Apparently I had that in mind. Page, hopefully it's 6.4 divided by the sine of 68, yes? 6.9? I'm also, Alyssa, trying to show, hopefully, how fast you can get at this, especially those of you that are taking any physics courses. You get almost bored, like, get it done and over with, and that's good, because then you're doing the physics, not the math. That's adjacent, right, Paige? That's hypotenuse. This one is cos. Theta equals 4 over 11. Wants me to find an angle. $68.7 degrees. Opposite, adjacent. Hey, it's tan! Tan of beta, that little funky letter there. 9 over 4, opposite over adjacent. 9 over 4. 66 degrees. Opposite, adjacent. Hey, it's tan again. 3.1 over 9.6. 3.1 over 9.6. Nicole, 17.9. Yes, not 17.8. Yeah, okay. 17.9. 18 degrees, basically. 17.9 degrees. Now we got some word problems. Hey, what am I going to do? Dulp. What did dulp stand for, Chelsea? And because we're doing trig, let's clue in. What's going to appear somewhere in my picture? A triangle. So, Colleen, here's the tree. Oh, I even gave it green branches. There's the tree. How tall is the tree? I think, Colleen, they're asking for that. How tall? If its shadow is 18 meters long, where does a shadow sit? On the ground. I think the 18 goes right there. And the angle that the shadow makes with the ground is 26 degrees. I figured that's going to be with the ground. Opposite, adjacent. Hey, it's tan again. Clear, Mr. Dueck. It's going to be 18 times tan of 26. 8.8 meters. Number 17, a ladder is resting against a wall. There's the ladder. There's the wall. There's the floor. There's the triangle. It makes an angle of 71 degrees with the ground. Gotcha. The base of the ladder is 1 point. The base would be right here. That's 1.6. How high up? Hey, once again, it's tangent. X is going to be 1.6 times the tan of 71. 4.6. Last page. Turn the page. And then we did say that there was a typo here, that I didn't want you to find XZ. What I really wanted you to find here was line YZ, or segment YZ. It says find everything. Okay. Well, I can find this. It's going to be YZ squared minus plus 13 squared equals 39 squared. It's going to be Pythagoras. 39 squared minus 13 squared. Square root of that, I have no idea. Does it work out evenly? No. Do you get 36.7? Or am I wrong? Oh, you know what? I read this wrong. That's not a 13. That's a 15, Mr. Dueck. Learn to read my own writing. Nikki, is that what you were wondering about too? No, you're just following along because you were away. Let me try that again. But instead of a 13, how about I put a 15 there? Is that better, Kiara? And I think this one will square root evenly. I think 36. Yeah! 36. That gets you, well, Nicole, how many marks is this question worth? How many things are you finding? How about 1 mark for each thing? Would that make sense? Yay, 36. Angle. Angle X. Okay. That's adjacent. That's hypotenuse. Colleen, which trig function? I agree. Cosine of X is going to be 15 over 39. The cosine of X is going to be shift cos of 15 over 39. 67.4. If you said 67, that's fine. I'm going to go 67.4. I can find the last one, Emma, just by going angle sum of triangles, because it's going to be 180 minus, Emma, how big is this angle? 90 minus, how big is this angle? Oh, we just figured it out. In fact, I'm going to use the answer feature of my calculator. And whatever is left should be 22.6, 23 degrees. If you said that, Tanner, I'm good with that, but I'll go 22.6. Number 19. XY. Okay, this I'm going to have to use trig for. Opposite hypotenuse. Sine 31 equals opposite over hypotenuse. I think XY is going to end up being 19 sine 31 close bracket. 19 times sine 31. Is XY 9.7, 9.8? People nodding? 1 mark. XZ, I could use Pythagoras. I could go 9.8 squared plus that squared equals that squared. The only problem is it's not 9.8. It's this, and I don't want to round up. You know what, Cole? I'm going to do trig again, just because. I'm going to call this here adjacent, and I'm going to use the 19 and the 31. I'm going to say cosine of 31 equals YZ over 19. The other reason is because on my calculator, I can just backspace, and change the cos of the sine to a cos. Am I wrong? We'll get close. Did you get something close to 16.3? I'll take it, but what did you get? What did you get? Okay. We're okay. Yes, Tanner. Quick like a bunny. You got 22? So show me what you did later. I'm going to guess it's a calculator mistake, or you accidentally found the hypotenuse. You didn't put this by its... Did you use trig or Pythagoras? So show me what you did later. You did, and you used cosine? And you had the YZ on the top? Ah, so you did accidentally hypotenuse over adjacent. There. So you get half a mark. Okay? So you got the right trig function. The angle. 180 minus 90 is 90 minus 31 is 59? Another word problem for 2 marks. Ladder. Wall. It forms a 68-degree angle. Ladder reaches a height of 2.6. How long is the ladder? I think that would be the slanty part, because that's the ladder. Adjacent, hypotenuse. Adjacent, Mr. Dueck? Quit doing that! Paige, I don't know what's going on. How about opposite hypotenuse? Sine. For some reason, I'm afraid to sin. I'm cosing. Sine of 68 degrees equals 2.6 over my mystery side x. Ooh, this is going to end up being 2.6 divided by sine of 68. You guys get 2.8? People nodding? So here, 1 mark for the trig function, 1 mark for the answer. And then the bonus question, and we're good to go. Let's see. Bonus is find side AB. That's x. I think first I need to find this. So I'm going to go adjacent hypotenuse. Cosine of 28 equals 22 over y. Y ends up being 22 divided by cosine of 28. 24.9. And now I can go opposite hypotenuse in the top triangle. It's going to be sine of 72 equals 24.9 divided by x. It's going to be this number divided by the sine of 72. Is the answer 26.2? 2 marks of bonus. Yes, 2. Here's what I want you to do, please. Add up your total quiz score, but then once you're done, divide it by 2 so that we get a score out of 22, because 44 marks is a lot. Divide your score by 2. If it doesn't work out evenly, 0.5 or whatever. And once you've done that, put a nice big score out of 22 somewhere at the top of the page and pass them inwards. Lesson 6, last day, we did more two-triangle questions, but they were word problems. And I said to you, Cheyenne, I will give you a picture if I give you a two-triangle word problem. I won't necessarily put all the numbers in for you. I may make you figure out where the numbers go. But, Nikki, I'll give you the kickstart if there's two triangles. They're a bit tricky. Okay. Any of these you want me to go over from the homework? Yes? Number 4. Is that the helicopter? Yep. Okay. Number 4. And, Kiara, I think I'm just going to do this to completely extend my triangle a little bit. And what they want me to find is that there. I think what I'm going to do is look at the big triangle, which has a 62-degree angle, 270, and find, since I already used x, I'll use y, that distance. That's from the ground all the way to the top. I think 62 is the whole thing. You know how I know? How big is this angle right here? I think 62 should be bigger, not smaller. I mean, I know my diagrams aren't to scale, but they're not god-awful. They're only somewhat bad. Okay? So you'll do that. That'll give you from here to the propeller. Then in the bottom triangle, which is 48 and 270, that'll give you that, and then minus. Yeah, this is a subtraction one. Is that good? Okay. By the way, if on a test, if you ever have a weird one, ask. And if you can't figure it out, I'll make sure I explain it. You'd be amazed. Well, I'll ask. Have any of you tried creating stuff like this in Microsoft Word? Like, one question takes about 20 minutes, which is why you'll notice on your quiz, my friend who made these up doesn't have a tablet. On your quiz, I handwrite the angles in because it's just so much faster than trying to nudge the angles sideways using words. Text for it's a pain, and sometimes you just can't fit it in. Any others? Then we start officially the new stuff today. Can you hand in lesson 6 if it's done, if you haven't yet? It's actually not too confusing. Somebody said this looks confusing. It's actually not bad, but what we have to add now when we see a triangle, we have to add one more question, and the question is there a right angle or not? That's the fork in the road that we're going to add now. Because if there's not a right angle, which is going to be today's lesson, okay, you have some new equations, sort of like an extra Pythagoras, like some new equations. Thankfully, they're not too bad, especially this is where those of you that have good calculators will appreciate this. Those of you that have the cheap garbage ones will be doing lots of typing. Today's lesson is the sine law. So far, we've learned how to solve for missing sides and angles only when they are used in right angle triangles. There had to be a 90 degree. And the tools that we had on our tool belt so far, Adrian, were Pythagoras, a squared plus b squared equals c squared. Trig, what was the dumb acronym that we could use to help us remember our trig? SOHCAHTOA. And then the angle sum of triangles, what was that one? Every triangle added to what? Okay, I'm just going to put equals 180. If you know two angles, you always know the third. That third one works for any triangle on the planet. The first two only work for those. It wanted us to do a review. Since we just went over the quiz, that was review enough. Instead, we're going to skip down here. We're going to say, now we're going to learn 2 more rules. We use these when there is not a nice right angle. Although they will also work with right angle triangles, but SOHCAHTOA and Pythagoras are shorter and less work. The first is the sine law. I have to teach you some new numbering. We can't use opposite, adjacent, and hypotenuse anymore because, Tanner, if there's no right angle, there's no hypotenuse. So here's what we're going to say from now on. If I call this angle right here capital A, the side across from it is little a. If I call this angle here capital B, the side across from it is going to be Capital C, little c. So what if, don't write this down, what if I called this capital F? What would I call this side here? Little f. It's a nice, easy notation. Don't have to learn any new variables or anything like that. Okay? It says, in the sine law, the sides are given lowercase letters of the angles that they are opposite to. The sine law states that the sine of an angle divided by its opposite side is equal to the sine of the angle divided by its side. Say what? It wants us to check this with rulers. Not going to worry about that. Here's the sine law. The sine of any angle divided by what's across from it is equal to the sine of any other angle divided by what's across from it is also equal to the sine of the third angle divided by what's across from it. Nikki, can you tell why we call it the sine law? I'm not going to prove it. There is a lovely proof. It takes about a page. It works. Trust me. Now, how many fractions do you see here, Nikki? 3. We only use 2 at a time. We put all 3 on the same row, but we're only going to use 2 at a time. And since I said fractions, you might have a guess already. It's going to involve cross-multiplying. 2. Example 1. It says, let's try to use the law in the following example. Cole, what does it want me to find? Which now, is there a 90-degree angle in this question? Then I'm not going to label it opposite, adjacent, hypotenuse. What am I going to call AC? What angle is this? So little b. What other angle do I know, Cole? So let's call the one across from it little a. And this is the pair that lets me use the sine law. This is the pair that I'm going to use the sine law to find. So I'm going to write the sine of big A over little a equals the sine of big B over little b. Emma, I didn't bother writing the third one because I only use 2 at a time, and I'm using A and B because that's the angles they gave me. Let's plug in everything we know. The sine of, Jacob, what always goes next to the trig function? Yeah, this is why I threw that at you about a week and a half ago. What always goes next to the trig function? What's angle A? There you go. All over. Jacob, what's little a? 12. Equals the sine of, Jacob, what always goes next to the trig function? Angle B, which is what? All over the mystery side that I don't know. Do I have 1 fraction equals 1 fraction? Then Kayla, you know how I can solve this? Take a guess. It's going to be cross multiply. Now, a little more complicated than the trig that we've done, because the trig that we've done, there was always a 1 somewhere in the equation. There isn't one here. It's going to be this times this, b times the sine of 41 equals this times this, 12, oh, don't change colors, Mr. Dueck, 12 times the sine of 82. Natasha, what am I trying to find? B. How would I get the b by itself? Because it's not. Well, there's that sine 41 next to it, yes? See it? What's happening between the b and the sine? Adding, subtracting, multiplying, or dividing? So how will I move the sine 41 over to the other side to get the b by itself? What's the opposite of multiplying? Yeah. Okay? We're going to go like this. B is equal to, so I'll make a little note here. Divide. I'm running out of room, otherwise I'd like to show that step. It's going to be 12 sine 82, this side, divided by what you wanted to get rid of and move over. Have we got the b by itself? Then let's go calculator. It's going to be 12 times sine 82. Natasha and Sam, you have to close a bracket off. Same with Rachel. Divided by, there's a bracket, find it. Sine 41, close bracket. $18.11. That's the sine law. The sine of an angle divided by what's across from it is the sine of a different angle divided by what's across from that different angle. We write it like this with A's and B's and C's, but I don't have to use A's and B's and C's. Let's look at example 2. Zach, what do they want me to find in example 2? DE. That's this here. What letter will I label this with? Little f. Now, to make this work, I do need the angle across from little f. Do I know this angle right here? Not yet. But do I know this angle? Do I know this angle? Well, then I do know this angle. What's this angle? Do the angle sum of triangles, please. How big is 57? Anyone else double check? Not that I don't trust Rob, but 57? Okay. So I have no problem giving you not the angle that you need, but expecting you to figure it out real quick. Now, I also know this angle here, but do I know the side across from it? That's not going to help me. I know this angle. Do I know the side across from it? That's my trigger. That's my key. That's what's going to solve this triangle for me. This is a pair, which is going to help me find this pair. Nikki, what letter is this? So my sine law is going to look like this. Sine of big D over little d equals, Zach, what did you tell me we're trying to find? Can you use the notation here that we've added ourselves, though? Little what? So sine of what angle is going to go up here? Letters first. Letters first right now. No numbers yet. Big F. Yes? What I want you to realize, Zach, is it's pretty easy to adapt this to whatever letters they throw at you. Okay? I won't always give you A's, B's, and C's. Sorry. Now let's plug in as many numbers as we can. Sine of, Zach, what's angle D? I agree. Divided by, what's little d, Zach? 8.3 equals the sine of, what's big F? All over, what's little f? Oh, what I'm trying to find. Zach, my friend, do I have one fraction equals one fraction? Say yes. Cross multiply. It's going to be this times this. It's going to be f times the sine of 41 equals this times this. 8.3 sine 57. Kiara, how would I get the f by itself? By what? Yeah, okay. Divide by sine, both sides by sine 41. Right? F is going to end up being 8.3 sine 57. And Natasha, why are we dividing to get the f by itself? Because you told us that it's multiplying, and we always do the opposite to move it over to the other side, right? Good. Go to your calculators, carefully type that in. And this is also where you want to practice typing in two trig functions on your, because there's a sine and another sine. Practice how this works on your calculator. In other words, see if you can get the same thing as me. I'm going to get 8.3 times sine 57 divided by sine 41. See if you get 10.61027348 dot 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 dot. If you didn't get, pardon me? See it now? Or do you need it to be bigger? 8.3 sine 57 divided by sine 41. And I'm deliberately not showing what I typed on my calculator because that's what you need to figure out how to do on your particular brand of calculator. And see if you can get the, was it 10.61? Is that what I said the answer was? See if you can get the 10.61? Yes? Okay. That's the sine law. That's the sine law to find a side. You can also use the sine law to find an angle. You know how you find the angle? Shift. Eventually. Example 3. Tanner, what does it want us to find in example 3? Okay. Check the triangle carefully. Is there a right angle, 90 degrees? Can we use something? Nope. Do I have a pair, though? Do I have an angle and the side across from it? Then I can use the sine law. Ready? Sine of, which angle do I know, Tanner? Angle what? Divided by, yep. Divided by little z equals the sine of big X divided by little x. Right? Cheyenne, how big is angle Z? Right from the, yep. Divided by, how big is side little z? Across from it? Yeah. Nice. Equals, trick question, how big is angle X? Why is that a trick question? That's what we're trying to find. So that's where the variable is going to go. X is going to stay there, right? Sine X divided by, how big is side little x? Yes. Okay. We can't quite get the x by itself because where is the x sitting inside sine? What we're going to do is get the sine x by itself. So I have a 9 here. Natasha, what's this 9 doing? Well, it's on the bottom of a fraction. I think that means it's dividing. Yes? So how will I move it over? What's the opposite of dividing? I'm going to get this. Sine x equals 9 times the sine of 84 divided by 12. Right? Is that okay, Shalom? How do I find an angle? How have we always found an angle? Okay, we're going to have to use a second function, but first, we need to change this into a decimal on our calculator. So on your calculator, we're going to go 9 times the sine of 84 on the graphing calculators, go close bracket, Natasha, divided by 12 equals, you get 0.74589142115, blah, blah. So here's what we're really saying. Sine x equals 0.74589 dot, dot, dot. That's not the answer. That's the sine of x. How do I find the angle, Shalom? I'm going to go second function, this decimal, which hopefully you still have stored on your calculator. Or use your answer button. You have an answer button, right? So go, this is what I do, Kiera. Second function sine of whatever the last answer was, and that should carry it to like 50 decimal places. And you do have an answer button usually next to the equal sign somewhere there. You should get 48.235722 degrees. So if you can't get that, now is your chance to ask me. Angle x equals 48.2 degrees. Okay. Thank you for telling me. That's easy to. That's it. That's the sine law. I just need to practice a couple more, but that's it, Joel. Not too bad, actually. Hey, a word problem. Example 4. Hole number 6 at the Genesee Lake Golf Course is straight from tee box to green. Anthony hits his tee shot 265 yards, but he shanks it 15 degrees to the right. Slices it. If he hits his next shot so that it approaches the hole at an angle of 23 degrees, he will be on target to sink the shot. How far must he hit the ball to make the shot? In other words, how big is this distance here? Okay. Is there a 90-degree angle in this question somewhere, Nicole? Is there a right angle in this question somewhere? No. So I can't use SOHCAHTOA, I can't use Pythagoras. Now, do I know this angle and that side? No. Do I know this angle and the side across from it? Yes. I'm not going to say that anymore from now on. I'm just going to say, do I have a pair? Do we have a pair? Yes. This is the job for the sine law. What's it going to be? Sine of, hey, let's see if we can go straight to plugging in numbers without variables. So the sine of 23 degrees, that's one angle I know, divided by, what's going to go with the 23? Yeah. Equals the sine of 15 degrees is the other angle that I know. What's going to go with it? X. Am I finding an angle? Is this one where I'm going to go shift button? Nope. Cross multiply. Here I have enough room to actually show it. I can show my work. Wow. I think you get 265 sine 15 divided by sine 23. What do you get? Sorry? 175.53. Anybody else? 0.54? I better try this on my calculator. 265. How about 365? 265 sine of 15. Yeah, I wish I could hit at 365 yards. Divided by sine 23. So it's Tiger. 175 point, you know what? Answer to the nearest what? Yard. 176 yards. Okay. Is that all right, Colleen? That's the sine law. The sine of one angle divided by what's across from it equals the sine of any other angle divided by what's across from it, and then cross multiply to find what you need to. Oh, okay, if it's an angle, you'll end up at the very, very end getting a decimal and going shift that decimal. What's your homework? Number 1. Number 2. Number 3. Now, take a look at number 3 for a second. Do I have a pair right here? No. Do I have a pair right here? Do I have a pair right here? Yes. No, you don't. Yes, I do. No, you don't. Do I know that angle? Do I know that angle? Then I do know this angle. There is a pair. It's just I didn't make it obvious. That's the pair you're going to use, and then it wants you to find the other two sides. This is actually 2 questions in one. In fact, it's going to be 125. Is that right? 125 degrees. Number 4. Number 5. Skip 6. 7. 7 says find everything that's missing. So see if you can slowly work your way around the triangle and find whatever is there. Sorry, can't use Pythagoras, can't use Socrates. I've got to use Sine Law for all of it. Okay. You got about 20 minutes.